So the title for today's talk is Evidence of Evidence. It's playing on words over here. Of course, what I'm talking about is building a chain of evidence that connects low-level data captured in the form of a multitude of modalities, video, audio, other sensors, and connecting it to very high-level constructs like collaborative problem solving, communication, and the kinds of skills that are otherwise a little bit tricky to assess with your traditional forms of assessments. So here's a quick outline of what's to come. I'll talk in more generic terms what is the key motivation, the market needs behind a lot of this kind of work, the technical challenges that we have to address to be able to create a solution, how my work in AI and machine learning, particularly multimodal analytics and hierarchical inference frameworks is a way to address those challenges. And I'll illustrate this in the context of 3 example studies that I've led in the past. One on measuring personality via nonverbal behavioral assessment, then another one on assessing team skills in the context of high-stress training tasks, and then a third one on assessing interactive English communication skills. And I'll conclude with a few remarks. All right, so what's the context over here? And if you're familiar with Sukat Ambitra's work out of Newcastle University, if you've seen his TED Talk, I think he articulates it quite well. I mean, it's not a very provocative notion to say that public education is still somewhat rooted in Industrial Revolution, where we valued skills like punctuality, regularity, attention, and so forth. And kids are still routinely tested on skills like ability to recall information and a mastery of a very narrow set of skills. The results sort of speak for themselves. There's a particularly high high school dropout rate, about 6.5% according to NCES, and the ones who do survive high school, almost a quarter or more, are just not prepared for the challenges of college and, of course, workplace after that. So that's just the state of the art as far as student learning is concerned, but pedagogy is not that great either. The World Economic Forum ranks US only 49th in 148 developed countries when it comes to the quality of math and science instruction. Couple this with the notion that the skills that you need to be successful in the 21st century is above and beyond reading, writing, arithmetic, and more traditional forms of skills being assessed. We're talking about things like collaborative problem solving, communication ability, interpersonal skills, the so-called 21st century competencies. Now, the challenge, though, becomes then, how do we assess, or how do we then facilitate remediation in these complex competencies? Because when we're talking about, say, interpersonal skills or communication, it is not just the end results that matter, or collaboration. It's the steps and processes that lead to it that we really want to get an insight on. Moreover, we want to be able to get to measuring non-cognitive behaviors, things like motivation, self-control, emotion, and so forth. And these are naturally very difficult to use paper-based assessments or self-review as well. Now, technically, and I'm going to try and see if I can fix this issue on Skype just real quick. Right, people are using this on Skype. Yeah, I dropped out. So hold on a second. I should try and log back on. Okay, so we have subscribed, verified. Loading, please. All right, great. So hopefully this is the last time we have to rescue Skype people. All right, so getting back to what I was talking about, assessing these very complex sort of skills, the technical challenges are obtaining objectivity, reliability, and scalability in making such assessments. Can we build automated tools, really, to assist humans in making such assessments and judgments? Now, somewhat paradoxically, it's not that we don't have enough data. In fact, there's a data deluge. There's a lot of data that's being captured in the form of audio and video, perhaps even log files when you're interacting with simulation and so forth. But the real problem is, how do you distill all of this data down into actionable insights? And that's what I mean by the difficulty in evidence identification. The innovations and the work that I've been bringing to the field can be sort of summarized in two areas. Multimodal analytics, to address this issue of evidence identification, capturing data not just with a multitude of sensors, but also building algorithms to process that to give you intermediate representations that you can actually process. And then building a hierarchical inference framework to enable or to bridge the connection between the multimodal data and the features that you extract from that and with the actual high-level construct of inference, which is kind of similar to how the human brain works, or even the recent advances in machine learning, particularly deep networks. Now, multimodal analytics, in a nutshell, we're talking about using AI and machine learning based computational models to measure behavioral attributes from the processing of this multimodal data. So if you look at this picture of a teacher engaged in a classroom, what can you tell about the level of engagement between the teacher and the students from the voice, from the facial expressions, the amount of eye contact being made, the body posture? Can we extract these intermediate representations of the construct from this kind of data and piece it all together to get to a better notion and a more better informed inference of the teacher being engaged with the class? I'll show this idea in another concept video. Doug Lemel, in his really excellent work, Teach Like a Champion, talks about several dozen behavioral attributes of good teaching. And one of them is illustrated quite well in this screenshot. So the teacher is occupying a spot in the classroom. It's just called hot spotting. So she's standing in a location where she can make eye contact with as many students as possible. Right? It's a good behavior. It's a good sort of skill to have. It's a very simple one too. And the interesting thing is that it's very tangible. There isn't an issue about the definition of it. You can actually measure that by figuring out, say, you're tracking the location with cameras or other sensors, what have you. You can also track their eye gaze location to figure out if they're making eye contact or not. Now, this is not to say that the content is irrelevant. Of course it is. But this is yet another channel of communication and good pedagogical traits that teachers bring to bear. Now, there will be others as I play this video. So the teacher just asked a question, and then instead of letting the first kid who raises her arm to answer, she's going to wait. All right, so a couple seconds, 4 hands, a few more seconds, there's 10 hands, and so forth. Now this is called wait time. All right, all this is doing is letting kids who need a little bit more time to comprehend the question, process it, to get engaged, other than letting the first kid always answer the question, right, which happens all the time. Well, there is another skill over here. She's just pacing down the aisle, so the audience, which is otherwise feeling a little bit neglected, feel, oh, okay, we're part of the fold over here too. Why all of these are important is because, to me, this is adding yet another complementary channel of communication and good skill in the classroom. But doubly important because you can tangibly measure this. You can use multimodal analytics and some fancy AI and machine learning algorithms to pick it up, tangibly quantify it, and actually use that as feedback. And it's a very simple skill to learn too. Now, the challenge, of course, is that sometimes these low-level behaviors look like, oh, if I just started pacing back and forth, is that going to solve my problem in teaching? No, it's just one small part of the bigger puzzle. And so we want to be able to fuse a lot of these small pieces together, ultimately towards making inference on the very top level competencies. And so in doing so, what I recommend is to create an intermediate set of representations, going from the very low-level data, like multimodal data that I was talking about. What would be the kinds of features that you can extract from that to use that for mid-level construct representation inferences, which in turn become the pieces of evidence that you use at the very top level. So, and notice, it's not just a bottom-up approach. This is both a bottom-up data-driven approach, but also a theoretical top-down approach. So what it's saying is that if I want to be able to understand how to measure collaborative problem solving, instead of just trying to connect and creating, say, a regression model between the video capture of a team trying to collaborate with each other and saying, this group of people are good at collaborative problem solving, this group of people are not so good, it's a regression model that would divide. Well, that doesn't really work. But if there was a better understanding of the construct itself, so CPS is going to be about knowledge assimilation, positive communication, resource sharing, and so forth. What does it actually mean to be knowledge sharing? What does it actually mean to be positive communication and so forth? So we can dig a little bit deeper based on the theoretical models and our understanding of those soft skills to say, okay, it might actually have an element of turn-taking. It might actually have an element of being engaged with each other or a positive affect being projected, which in turn is a function of speech prosody, facial expressions and gestures and so forth. So what we talk about over here is using the theory as a guide to say, what are the sub-skills and the sub-skills of the sub-skills, kind of like, a taxonomic representation of what the construct is all about, and how do we link it up with the data that we actually have, which is very unstructured and noisy and so forth. So it goes back and forth like that. And that's what I mean by evidence of evidence. So the evidence at the very top level, how do we actually connect that to the low-level data? That's the, I don't know if it makes grammatical sense or not. Anyhow, so that's the theme of the talk, and I'll illustrate this in the context of 3 studies that I've led. And instead of going in one particular study all the way down, I'm going to talk about various aspects of this framework in these 3 studies. So the first one is going to be measuring personality attributes using non-verbal behavioral data, where I'll talk about more about the theoretical model. Then I'll talk about number 2, which is assessing team skills in high-stakes context, where I'll say a little bit about how, what sort of inference engine that we can actually use at the very top level once you've connected the chain of evidence. And then the third piece is going to be assessing interactive English communication skills, where I'll focus more on the low-level data and the classifiers that you can build on top of that. All right, study number 1, on the signals, and this was motivated in part by Cindy Penson's work at MIT, if you're familiar with that. So what they had developed was a sensor, a wearable sensor, that would allow you to pick up on low-level data and turn that into behavioral cues as sort of your handles into better assessing a multitude of different contexts. So my interests were that, is there a way to assess personality in vivo, as in real-world context? So this is not necessarily saying, okay, you're sitting on your desk and you can respond to forced choice questions or a situation adjustment test or what have you. We're talking about actually groups of people working with each other on any particular task in vivo in the real-world context. Can we pick up, first of all, data non-invasively? So wearable sensors made a lot of sense in that context. And then can we automate the processing of that data to link it up with the high-level personality traits that I'm interested in? In doing so, what I proposed was this trifecta of approaches getting together. One is to essentially, what is the kind of task that you ought to be using to elicit the behaviors that you're interested in? So it's fine to say, in vivo and people in realistic context, but what would be the right kind of task to give them, and what sort of problem-solving task do you want to give them that will allow you to make or elicit the behaviors that are necessary for the inference? then what is the relationship between those non-verbal behavioral attributes and the big five traits? That's where the three sort of the cogs of the wheel come together: the task, the BFI traits, and the task the non-verbal behavioral attributes. And there's a nice research report that we published a couple of years back on that. And here's a snapshot of it. And by the way, if anybody has questions as I'm talking, please feel free to interrupt. So think of it as a crosswalk between three dimensions. On the one hand, you've got a crosswalk between the sensitive data and the BFI traits. So the sensitive data is things like number of speech segments, the number of turns being taken, successful versus unsuccessful interrupts, proximity, and so forth. A lot of non-verbal behavioral data that's coming out. And then we scour literature to figure out, based on what the state of the art is, what are the relationships between this kind of data and the big five traits, like extroversion. So it looks like being extroverted is highly cited in various pieces of literature, with being interrupting in speech. So, all right, the guy who's very dominant in a group of people conversation, they tend to make a lot more successful or sometimes unsuccessful interrupts in the conversations. So that is not to say that covers the entire spectrum of what that particular trait means, but it is one nugget or one piece of evidence that relates what we can measure with making a more informed inference on that particular trait. The second crosswalk is to connect now the kinds of tasks with the low-level behavioral data that we can actually pick up. So some kind of task might be better suited to elicit certain kinds of nonverbal behavior. So in that context, we used McGrath-Stark's the task circumflex. This is actually pretty seminal work back from the 1980s, in which he created a nice representation of the entire space of possible tasks. They could be either conceptual tasks or behavioral tasks. They could be cooperative tasks or conflict resolution tasks, sort of this 2D grid, and then he had further facets of it lined up. For this study, I tried to use more of a negotiation task, which has got more decision-making and cognitive conflict resolution aspect to it. The tasks were designed as such. So it's called a new store purchase task in the sense that the 4 people, which are part of it, we just use 4 people groups. Each person is assigned a role of being a vice president of the company, and they just basically have to have a conversation as to where do we want to invest the resources of the company to expand it. So one could be VP of finance, one could be VP of operations, and so forth. And we found this task to be very rich as far as eliciting a good discussion between the people. This is the sensor that I was referring to earlier. It's called sociometric badge. It's kind of like this. Your work badge is obviously a bit thicker, and it's got a multitude of sensors. It's got a microphone, an IR sensor, accelerometer, Bluetooth, just to sense where in the building you might be. So those are the low-level, actual modalities that it's picking up on. The features that we can get right out of the box from the multimodal data are things like speaking time, number of speech segments, tone of voice, angular motion of the upper body, which you can imagine you can use for things like if somebody's oriented towards somebody else, right? So that's another interesting behavioral cue that people use in group settings. I'm talking to Ada for a second, and Martin asked me a question. My body will still be oriented towards Ada, but for a moment, I'll turn my head towards Martin as a cue to Ada that I'm going to come back to you. So these are the kinds of behaviors that, in literature you find that people use in communicating across groups. And you can certainly measure that kind of behavior with a sensor like that. But then we can also build some intermediate representations, mid-level features from this kind of data. Dominance as a function of the amount of time that people speak in group settings. Who's talking more versus less. We certainly see that happen when you've got presidential debates, right? Turn taking, number of speech onset and offset. Who is taking a turn with who, and who's actually passing the baton on to as far as who speaks next. Successful versus unsuccessful tricks, interrupts. So people, a diet is having a conversation, and somebody jumps in. Mid-rate, which is more based on the motion of the torso, balance and centrality, other features which are based off essentially a combination of the others. Some preliminary analysis. Here's a snapshot of what the data capture looks like. The people interacting with each other. What you see on the top left is a participant chart, as in the entire exercise. This pie chart is telling you what fraction of the entire time duration was the blue individual speaking. There are 4 people. They're all color-coded according to different nodes over here. It's not about this, the shirt color, but these are just the defaults. So clearly, the individual who is the blue node is speaking more than, say, the green one. The interactivity chart over here is interesting because it's trying to tie together who's speaking with who else. So each colored node is the same concept over here. Actually, the radius of the size of the circle represents exactly this data. But the edges between the nodes represents the turns being taken between those 2 people. So if it's a thick edge, that means that particular pair is having a lot more turns with each other than somebody else. The interesting thing that we can notice from just the interactivity graph is that it almost looks like there's a little click that's forming over here, where the green individual is not really so much part of the loop. At the bottom over here is a time series of the spoken content. So when one is speaking, sometimes the other is trying to speak over them as well. A second sample, similar distributions of participation. Certainly another click that one could interpret if you were to take very strongly my earlier definition, but maybe not. If you look at this chart over here, something interesting is taking place. Even though the blue individual is not speaking nearly as much as the yellow or the green one, but when they do speak, others tend to listen. So maybe there's some interesting power dynamic over there that is worthwhile exploring. All right, so that was the first piece to talk about what could be a potential overarching theoretical model to utilize in these contexts. I'm going to talk now and switch gears about a second study where I was working on a project to develop a new tool to assess team skills in high-stress scenarios and also provide feedback for remediation. And this was a program funded by the US Army, and they're very much engaged in creating training opportunities for warfighters to engage with patients in multiple casualty scenarios. So there is a natural catastrophe or what have you, and then the medics approach that team, and how do they actually handle that? So how do they figure out how to do triage? People are injured and bleeding, and so how do you balance the high stakes and high stress situation? And it turns out a lot of the skills are very much kind of like the skills that we talk about in 21st century competencies. Who's a good leader? I mean, how are you communicating with the team? And so forth. So it was, even though this was a program that I led while I was at ETS, there was still value of what we learned from contexts like these in the educational space. And here's a concept picture of what the program was all about. It's a mixed reality training program. So what I mean by mixed reality is that the trainees, these warfighters over here, they're engaged in a real-life-like training scenario, which includes virtual worlds being projected onto the walls of the 360 environment. So there's like potentially an opposition force shooter in the background or what have you. So that's taken into context when the trainees are trying to address the multiple casualties. And then you have real role players, people who act like they're injured and so forth. So the trainees actually get a very realistic experience. As they're engaging in the training scenario, we use multimodal sensors, so the cameras and microphones, 3D sensors that are being used to capture what's transposing or taking place in the entire exercise comprehensively. And this data is then used to actually extract various different nuggets of information and pieces of evidence, kind of like I was trying to describe earlier, to inform our assessment of the high-level competencies. Now, what are those competencies? So this is pretty much what I was just summarizing. You've got multimodal data coming up, multimodal behavioral analysis using a lot of AI machine learning-based classifiers. informing us on things like affect, behaviors, specific speech utterances, interaction measures, and so forth. By the way, this program also had the interesting aspect that in addition to using sensors and some automated analysis, there were also human raters in the room who would actually be observing the behavior and the trainees and jotting down notes, and actually we also built a mobile, like a tablet-based tool, and that information is also going to be ingested into the evidence gathering. But the key piece that I just want to spend some time today on would be how do we take that to make inference at the high level for things like situational awareness, leadership, communication, and support. And the basic psychometric model that we used over there was a Bayesian network. So how do we combine evidence to make the inference on both individual and team level competencies, where the observables are no longer the raw metadata or the raw multimodal data, but analysis on top of it using multimodal analytics to get to specific behaviors and speech utterances and so forth. So that becomes your observables, but we can actually flesh out the relationship between the high-level construct like leadership and situational awareness and its associated sub-skills, and then the relationship across them to let the observable data propagate up this chain of evidence relationships, at least based off of our more SME-based representation of what would be the right relationship. So what would be the conditional independences between the sub-skills between communication and leadership and so forth. So the point being that Bayesian networks is actually a pretty decent approach to use, and it's well documented, well researched, to convert a taxonomic representation in actually a computational form, which does take into account the relationship that an SME would have identified. Now, but it also gives you the groundwork and the framework to update those as you get more data to figure out, okay, I'm seeing one particular relationship over here, figure out a little bit more in the actual data that's being captured based on how when you train a model, what the weights are telling you, that a particular relationship that an SME thing is crucial may not necessarily be borne out in the data that's being captured. So if we zoom into, so this was the very bird's eye view level and also not showing you much of the detail, but if we zoom into the communication branch, based on the SME, so in this particular context, working with the warfighters, we realize that when they talk about communication in these multiple casualty scenarios, they're talking about exchange of information, which in turn means you've got to make sure that you're closing the loop. So, and I said something, the other person acknowledged that. So that's closing the loop. That's one behavior. Another is supporting information on patient communication and so forth, which in turn use leaf notes like tone of voice, human ratings, and so forth. So this is where the observables will come in, and you would let the observable data really propagate up the chain. All right, so that was piece number 2. How am I doing on time? Good. We got 15 more minutes. That illustrates how once you have actually built the groundwork to take the low-level multimodal sensor data, extract meaningful pieces of information from it in the form of classifiers that are trained to recognize for certain phrases, certain behaviors, or what have you, how you can actually take all of that data and fuse it to make an inference on the very high-level competency, which takes into account what the SME or the theoretical model of the construct is. This study over here, I'll talk more about how do we actually build some of those classifiers to take the low-level data. This is called the Multimodal Assessment Platform. It was specifically designed to assess English language communication ability, potential users being universities, admission offices that need to get more of a sanity check on non-native speakers' English speaking ability, even if you've got your TOEFL scores or IELTS scores or what have you. In fact, a lot of the university offices are already doing that. You've got your score, the GRE score, your SAT, ACT, what have you. they would still have a quick Skype chat or a phone conversation to validate some of that. Now, that is very subjective, and it's also very time-consuming. And so my thinking was that could we automate that in some fashion? And potentially, of course, have opportunities for English language learning as well. So here's a quick overview of what the system was about. An online Skype-like interface that allows users to have interactive dialogue with each other. So essentially, you can think of it, the first rendition of it was simply that you would have a Skype conversation with actually a real person. You capture the data, process it, and so forth. But the holy grail is to have a completely autonomous virtual avatar engaging you in a very plausible fashion and still giving you the kinds of valid data that you can base inference of the assessment. So you got the interface to capture and engage the user. Multimodal data is what we can then process for low-level machine features. The analysis to extract evidence, I structured it along at least 4 different categories. Speech delivery, so I'm talking a bit more about what kind of features I'm referring to with that. Language use, behavioral engagement, affective engagement, and the fifth piece was security biometrics, which is ancillary to the actual construct of interactive speaking. The low-level features, when we talk about audiovisual data, with audio, a lot of the features that I'm using are things like energy, spectra, melt frequency system, zero crossing, ASRs, and so forth. This is essentially features extracted from the audio spectrum. From video, similarly, we talked about features like histograms with gradients, which is this rendition over here. This facial image can be converted into a pixel representation of patches called histograms of gradients, which is essentially just capturing in a neighborhood of every pixel what is the distribution of gradients, as in where the pixels change, kind of like where the edges might be. Facial landmark points, which is what you see over here. So we can actually track in real time facial features, where the eyebrows are, where the eyes are, cheeks, bones, and so forth. And this is, think of it as the low-level feature that you can base the detection of mid-level concepts like facial expressions. So what is a facial expression? It's a part, say, a smile is a parting of the lips. So if I was able to actually track with higher degree of accuracy facial landmarks around my lip, and if I see significant deformation over there, what does that actually tell me about somebody smiling? And you can build classifier on top of that. Action units, which is a collection of facial landmarks, and facial expression that we just talked about. So that's a very low-level data. Then we can process that low-level data to get to mid-level features. Say, let's first talk about delivery. This is more on the speech side of things. And delivery over here, the concept encompasses both fluency and pronunciation. And we use 11 different features in the subscore model for delivery. So these features include things like number of words, number of lexical types, mean deviation of words, and so forth. This is a lot of S&E work that went into discovering these, as well as a lot of regression analysis to figure out which might be more useful. So this is after a lot of the filtering from the entire laundry list of potential speech features associated with fluency were selected. Same as the case with pronunciation, but slightly different. So with pronunciation, we're talking about sum of word level acoustic model likelihoods, sum of weighted word level ASR, and then automated speech recognition competence scores, and so forth. With language use, which was the other one of the other 4 constructs, we're trying to capture grammar and vocabulary, and there were 7 features in the language subscore model. For vocabulary, we have distinct lexical types. Simply after ASR has been done, we can do that. Average frequency of rank of lexical types, similarity of words, and so forth. And with language use, we talked about more using in the language. It was more how the spoken content lined up with the automated speech recognition model. So, normalized ASR language model score. Then, and by the way, so with these would be the features that we'd extract from the low-level data, and there's after that actually a regression model to score for the subscores. For the engagement, mid-level representation, I use two submodels. One is trying to capture behavioral engagement, designed really for on-task behavior. Are you looking into the camera, or are you so distracted, you're not even in the frame of video frame? And the second is more on the affective side of things, the affective engagement, positive affect and emotion versus a sense of frustration and so I'll give you a couple of examples of what I mean by that. So with behavioral engagement model, just designed to capture on-task behavior, we're using an SD called OpenFace to track facial landmark locations, which I listed earlier, as well as head orientation and eye gaze. So you can certainly distinguish this from that. So based on the amount of time, it's a scanning window sort of an approach. All right, so how many, what fraction of the time was the user not even looking into the camera, or looking away at significant time? So there are of course some nuances over there. With affective engagement, as I said earlier, we're trying to capture positive arousal and positive balance. So if you're not familiar with the affective computing literature and lingo, arousal is a notion which is capturing individuals' global feeling of dynamism or lethargy. So if you're really animated, you're on high on a degree of arousal, but if you're very passive, there's really hardly any emotion to you, you're not very aroused. And valence is trying to capture whether it's a positive emotion or a negative emotion. All right, so wheel or what? So if you're very exciting and bubbly and happy, you're more on the positive side of things versus if you're looking very pensive. And so you can imagine that, and this is essentially one of the key advances in affective computing, is to really distill a lot of human behaviors along this 2D grid of arousal and valence. So most of the universal affective states, like being confused or being frustrated, what have you, it could be put along a particular quadrant, so to speak, on that space. The data set that was used to train for this model is called Semaine. It's publicly available. About 95 different conversations between dyads, two people having face-to-face talks. Significant amount of data, 8 hours of audiovisual data over there. And it's fully continuous in the sense that the entire time series has been annotated by human raters on that arousal and valence scale. Every frame or minute, second to second is annotated by multiple raters, and there's integrated availability and so forth on top of that. Here's a little video.
Spike? People who judge it for no reason.
Let me show you this because
Actually, criticizing people.
As you can see from the video, it's authentic, plausible. These are not just actors acting out a particular behavior. And when they're having a dialectic conversation with somebody else, those are the actors who are trained to elicit very realistic responses along the spectrum. All right. So here's that arousal and valence chart that I was talking about over here. And all the dots over here are the human ratings from that entire data set. So some of the videos have obviously examples on this quadrant and so forth. What I'm trying to capture with the construct of affective engagement is this quadrant, where you have high valence, positive valence, and positive arousal. So I'm trying to build a classifier for that specific combination and using this data. And sure enough, we have pretty reasonable success on top of it, using facial features like head pose, eye gaze, action units, and so forth. I know Praveen is telling me I'm running out of time over here, and everybody has a 1 o'clock hard cutoff, particularly leadership, so I'm going to try and just end this very quickly with a quick demo. So The demo over here will showcase what the system was built with a human interaction. Ultimately, the goal was to go to human avatar interaction. So let's play.
Hi, Yuli. My name is Mrs. Henry, and I work for the Educational Testing Service. How are you doing today?
Hello, Mrs. Henry. Very nice to meet you.
I guess you are wondering why I called you. This video conversation is to be a follow-up from the TOEFL test you recently took.
Oh, okay. Just me? Why you want to talk? Is there something wrong?
Oh, no. There's absolutely nothing wrong. The purpose of this meeting is to better estimate your English language speaking and communication abilities. I will be asking you a few questions about yourself, your background, and your goals. Are you ready?
Oh, yes, Mrs. Henry. Okay, what do you want to know?
Okay, first question. When did you first start taking classes in English?
Oh, I started English lessons in middle school. So, let's see. I was about 10 years old.
Okay, and how many classes or hours a week did you spend on learning English?
In middle school, we started with one class a week, and that was 2 hours. And then it was, what's the word? Increase. Yes, increase. So by high school, we had English 5 days a week, 1 hour in length.
Excellent. And did you have opportunities to practice your English skills outside of school?
Not everyone in school like it, but I really like learning English.
Okay, now tell me about your academic plans.
I am majored in business administration and well to get a master's degree from American University. And my parents think it is a good idea for me to study in the USA.
That sounds like a smart idea. There are a number of quality MBA programs offered by universities in the USA.
Yeah, I think it is a good move too. I have applied to 5 schools, but I do need to get a good score on the TOEFL exam.
Yes, and having good English communication skills will help you obtain an excellent education in the US.
Great, that's exactly what I want. Anything else, Mrs. Henry?
No, I think that just about covers it. So thank you so much for talking with me, and good luck in your future endeavors. Goodbye, Yuli.
Okay, goodbye.
Okay, and then the video proceeds to talk about, to show the different tabs over here, which are capturing the soft skills that I was talking about earlier: fluency, language use, social aspect, and so forth. And that was basically the vision over there. By the way, this was not a real test taker. This was a friend of mine at ETS, and all of this is publicly available in the sense that it's published and so forth. You can check out the paper. All right. So, but there are potential other uses to this too. We can talk about better assessing, say, interview candidates along similar dimensions. There's also potential use in collaborative problem-solving skill assessments, and certainly we've, even at ACTNext, been exploring that. I'm going to just now go ahead and conclude by saying that I believe there's a really important and growing need for objective, valid, and scalable assessment of the so-called 21st century competencies, including social and emotional skills. To be able to address that need, we have to work on innovations in evidence identification, captured through data in multiple modalities, and I think using multimodal sensing, analytics, and hierarchical inference models is certainly one way to address that. A lot of this research is at the confluence of a multitude of disciplines. We talked about SMEs and theoretical models as well as data-driven approaches. So AI, machine learning, computer vision, and NLP on one hand, but also psychometrics, cognitive science, and linguistics science on the other. With that, thank you very much.